right, that's kind of promising. Oh, that actually worked. Uh, okay. Portrait. Huh. Okay. Hey guys. Uh, just getting things set up here. Excellent. Okay. Insta is. Hey Timo. Insta's working. Wonderful. Restream's working. Uh, it looks like YouTube. Yeah, for sure. If you guys are getting kind of weird output on Insta, feel free to hop over to YouTube. Let me just grab that link for you. There we go. So you can follow that link. YouTube's pretty reliable. Some people like Twitch, and we're on Facebook as well. Let me actually drop all of those just so you guys can choose. I think YouTube's pretty great. The only thing I think is if you're not a Premier member, I think it sometimes doesn't. Hey, sweet, Orange County. Love it. And I love Orange County. By the way, we've tried to fix the double line output on this thing. And so, in theory, Claude and I worked on it after the live stream yesterday. So, in theory, it should actually be solved now. Hey, Becky. Becky, you're on. Oh, come on. Okay. Hold on. What if I don't? I think that's something to do maybe with the. Oh. Okay. Looks like we still have more work to do. But at least we're not getting the double line output yet. We're going to hold our breath here. I don't want to say too much about it because I might just jinx it. But yeah, feel free to give roll call. I see some people are already dropping in from Orange County. And as always, dialing in from NorCal over here. Oh, let me update the Discord. And I'll drop all of those. By the way, yeah, yesterday I think we broke 400 subs on our Discord. So pretty excited about that. And I think we got something like 5 new members on YouTube. So, oh, awesome. Thanks, Clint. Clint's saying, I joined your Substack, but I'm wondering about the link to join Discord. And also one other thing. Hey, Elle. Since you said your number one rule, MD, is to never use absolutes, why is this? Oh, for the literals. Yeah, that's a great one. Let's actually... Oh, hey, thanks, Cert. I love that. Thank you guys so much for joining as members. That actually helps us with some of the recurring expenses for like Restream and Opus Clips and Claude and all that nonsense. But this is a great thing to discuss on why we should avoid literals, absolute values in code software. Clint is asking this. Clinton. Yeah, maybe I'll talk about this first while we wait for people to roll on in. So let me see how I can explain this. Okay. One of the most important things in software development, in my mind, is it's not simply... By the way, let me know if the mic volume is good. I actually turned it up quite a bit from yesterday. I was listening to the recording afterwards, and I had to do some major up-leveling. So I think it's better now, but let me know if it's coming in okay or if it's too loud, if I'm clipping or anything. Anyway, so going back to... Awesome. Thanks, Vic. And while I'm explaining this thing about the literals, feel free to drop in where you guys are dialing in from. I always, especially if you're new, I just love to know where people are coming from. I know like 50% of you guys are from the US, but different places in the US is interesting. And it seems like we've got a pretty good audience from Western Europe and then Australia, United Kingdom, stuff like that. But yeah, feel free to share. Okay, so going back to why we should avoid literals in code. All right, so let's go over here and let's look at this. Now, here's some code. Now, you'll notice that in the test code for GCC, there are literals, and mostly I let that slide because it's sort of like Claude seems to think it's significantly more work to actually... Oh, awesome, Cert. I've been to Delhi, by the way. Romania. Wow, yeah, that's awesome. I haven't been to Romania, but I have been to India a couple times. I did some software engineering teaching over there I think I visited for like 3 weeks or something. And let me tell you, it was hot. I think I went in like July, and oh my goodness. The temperature plus the humidity was... I spent some time in Chandigarh, I think that's where I was. Sorry, a little tangent here. Chandigarh, India. I think this is where I was. Yeah, cool. So I flew into New Delhi, and then I think I took the train up to Chandigarh, and I was there for. Can you guys see this? There for about 3 weeks, and I was actually teaching software engineering principles, specifically on how to build large-scale software in C, C++. Hey, uh, Verg, thanks for joining. I love that. This just warms my heart. Uh, and I went out there, I think, in July, and oh my gosh. So it was over 100 degrees Fahrenheit. And I lived in Arizona for a while. So, okay, sweet. Uh, Becky saying, I'm the size of a wall on the big screen now. That's awesome. Texas. Excellent. Yeah, we've got quite a few people from Texas. Anyway, so back to the story of Chandigarh. I think I had to go out there in the summer, and I've been in hot weather before. I lived in Arizona for almost a decade, maybe. But I'd never been in heat where it was that humid. And I mean, I was just covered in sweat the whole time. Even the place that I was staying in, I think even with an AC on, it never got below maybe 85 degrees. And I'm, being from Colorado and stuff, I think I was more acclimated to that kind of weather. And so this was a good learning experience. I'm very impressed for all of you from India that can handle that much heat. You're very hardened people. Anyway, okay, so going back to literals and why these can be really bad if you use them in your code. So I think a lot of people that are new to software, what they try to do is they try to create code that is functional, right? You want to create a software system that does what you're intending it to do. And that's a good goal. I think that should be, in many cases, the first goal for all software systems. But as you become sort of more experienced in software, what happens is you start to realize that simply having functional software at any specific point in time is not sufficient. And the reason for that is if the software is getting used, then you will more likely than not have bugs you need to fix, and your users or yourself will want new features to make the software better. And one of the big aspects that software brings that other systems don't bring, oh no, okay, sorry about that, Stu. So with software, one of its main strengths is its flexibility, its permeability, the fact that you can change it very easily into something else. And most industries are not like this. Specifically, anything kind of in the physical world is really locked down into kind of the physical representation. So for example, when I was at Intel for 13 years or so, it would take us, I think, 4 or 5 years to build out a new processor. And if there were any mistakes in that processor design, correcting that, depending on how far it was in the staging, would take upwards of 2 years to correct because things are, hey, Nigel, or Nguyen. So in the physical world, you kind of burn things in and you expect that it's going to stay fixed in that shape for some period of time. The model of a car, your phone design, your TV design, all that stuff. But with software, because it lives in the virtual world, the ease of iteration is one of its biggest strengths. And this is also why I think software has kind of taken over the world, because it can adapt very fast, right? Like I can have something new and fancy in GCC in 3 or 4 hours, whereas, hey, thanks, money. Whereas trying to make these types of changes in something more physical could take 100x more time. All right. So one of the key superpowers of software is its ability to be flexible, its ability to change. And as you build more and more software systems, one of the most obvious things that kind of jumps out at you, at least for me, is that these systems are going to want to change if people are using them. Like there's a saying that I have that the only software that doesn't change is software that's not being used. So if you get a piece of software that you're not seeing changes in the code base, it's probably because nobody is using that software. And that's even true for cases where you have the piece of software and it's complete. Like, not that I believe in such a thing, but let's say that you build a piece of software and it turns out that you actually are done. I guess maybe for classical mathematical problems or something, like if you're just building the concrete specific design elements, then maybe once you get those right, it won't change. And then maybe you're done. So like the calculator app, I guess maybe is a good example, right? We get this baby coded properly and we have all the core calculator functionality, then we're done. But not really. Because even in this case, what can happen is the core functionality can be right, but the ecosystem around that calculator app can change underneath it. This is happening all the time because operating systems are advancing, libraries are advancing, browsers are advancing, and each one of those updates has indirect effects on the existing software. Sometimes if it's done elegantly, like it's backwards compatible, you won't have to make these changes, but a lot of people don't like always follow this rule because supporting backwards compatibility can be somewhat challenging. At Intel, we tried really hard to not break backwards compatibility to things like x86, but there would be cases where if you wanted more advanced functionality at the hardware level, things like gather and scatter or vector operations, then you would have to change the original application to use those newer fancy things like SGX, all that kind of stuff. So the point is that all software that's being used is likely going to have a lifetime where it'll continue to change all the time. Now we go back to the literals. What literals do is they bind you to specific values that inhibit that flexibility. So this 1 in 5, first of all, one of the problems with the literals is, what does 1 in 5 mean? Like, it's not immediately obvious to me. And so this is a bit of a problem because we want the code to be perfectly understandable. So then when any random person that's never seen the code before but knows how to read software code would be able to look at this and say, oh, I know what this stands for. So this is one of the first problems, is when you just use the concrete values, they don't necessarily, they're kind of like magic numbers, and they don't necessarily intuit their meaning. But the bigger problem is that you're bound to a static data point. And so when these numbers need to change, like this number needs to change to 6 or 12 or something, you then have to go through the code and, hey, Dark, you go through the code and figure out where all the 5s are and change them. Yeah, that's okay. We're actually just talking about literals in software real quick before we get into the AI boom stuff. Clinton had a question about my number one rule on never using absolute values. So when you use these absolute values, first we have to go and find all the 5s. But here's what makes it even more tricky is, what about 5s in the code that mean something else? So you have this 5 here, and in this case, maybe this has a constant meaning, but maybe we go into some other file and there's another 5, right? Like maybe that's a bad example, but you can see that, again, test code, I kind of give up just because it's so painful yelling at Claude constantly. But for any of the actual core system, I try to make sure that all the literal things are going to be stored sort of in these JSON blocks outside of the code. Anyway, let me see if I can show you some sections that will give you kind of an example. Okay, so this kind of structure is much preferred for me. And this is like 2 levels of indirection. What's going on here? Here we have a concrete name for this string, so we're going to call it a new line. And this gives us basically a key identifier, so we know exactly what this constant means. Then you'll notice that inside of here, the reference is to a JSON file in this thing here. And so that's another degree of indirection, of abstraction. And then what that allows us to do is, this is actually a really important minor detail, is when you move the concrete values that are bound to the constants outside of the code and into data files, then what you can do is you can augment the runtime behavior of the software system without ever changing the code. So for example, if I want to change the actual underlying definition of new line, I don't actually change the code here. I just go into this JSON file and I augment this JSON element. So there's these 2 degrees of separation. And then that allows you to do really awesome things, like change the runtime behavior, the style, the look and feel, all without ever changing the code. So anyway, I could probably continue down this rabbit hole for hours and hours, but Clinton, does that kind of make sense on why you want to pull out these absolute values and these literals and instead store them in things like JSON files, XML files, just sort of separate files that, like the way that I try to structure it at a very high level is there's source code and then there's data. And in the source code, that code should be principally operational code. It should be things that we have it because it's doing specific operations. And then the data files are the things that basically have everything related to data that feeds into those operations that then drive the system. But you want a clear separation of those two. And then by having that separation of the data out of the source code, it allows a very dynamic updating nature of the software system without ever rebuilding the binary. And I know that like in some languages like JavaScript and Python, it's not really that important because it's a scripted language. And so it's interpreted kind of at the runtime. But for really fast systems, systems that live in the system software, so things like operating systems, browsers, any of the actual implementation of the neural nets for the LLMs and SLMs, where you need the performance to be extremely fast, you really want to have that separation of data from the code. It just allows things to be significantly more modular and flexible. So for example, in Notica, at some point maybe I'll show you guys the Notica code. Basically, none of the resources for the Notica game are in the source code. It's all resource files. And what that allows me to do is I can change any aspect of the game that has to do with the style or the content completely without ever shutting down the server. And so that increases like its reliability. I'm really keen on building kind of like these software systems that are serious production quality and extremely hardened. Like I don't like when software crashes. I think that it shouldn't. I think really good software should probably have a 5 or 6 nines uptime. And doing this type of structure will allow you for that. Anyway, yeah, exactly. And I do think that it also can make it more secure. Yes, because then you can do additional things that allow you to encrypt the data. Whereas if it's just in the source code, like a password or something, the source code is, if it gets shipped or the symbolic information gets shipped, it's going to be visible for people that are inspecting it. But if it's in an encrypted data file, it will be ciphered, right? It'll have that layer of protection. So absolutely, Clint. Awesome. Okay, cool. This was huge on, yeah, absolutely. And I know that, uh-oh, is it doing it? Okay, hold on. Let me yell at Claude real quick about the double output thing. We worked on this and it was like, I've got all these fixes, blah, 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 bloobity blue. And no, you don't, buddy. Okay, hold on. All right. I'm just taking a quick screenshot of this. Sorry, guys. We're going to be... What I really want to do is I really want to start doing live streams every day. That's really what I would like to do. And to do that, one of the things I was thinking is I'll be actively kind of coding or working on like the Stanford content or figuring things out with machine learning, AI in the live sessions. Like, for example, augmenting and improving the GCC system while we're on the live stream. So hopefully this doesn't annoy you guys too much you can talk amongst yourselves for a moment while I send this over to Claude, see if we can fix this thing. This one's tough because I have to debug it while we're live. We tried to do as much of the testing as possible offline, but man, that's bad. But we couldn't see it because we had a hard time reproducing live stream chat. Okay, Claude, the double print is terrible right now. See the last two screenshots. How can this be this hard to effing fix? Figure out what's causing this now. Okay. All right, so let's just change this a little bit. I think it's with the renderer. I think it's a renderer problem. Okay, so now that we're done kind of explaining that, any other intro stuff people want to talk about before we dive into the core topic, which is, here's the core topic for today. This guy. I saw this on one of the channels that I follow, and I got just super excited about this. So I want to read this to you guys. And we can all deliberate on this, and then I'll share with you kind of what I think. So the post is from this artificial intelligence channel. Reddit user explains how LLMs have improved so rapidly in just a few years. And then yeah, seriously, Jack, that's exactly what I'm saying. I'm about ready to go in and stare at the code myself. I've just been so busy doing all the other things. I thought that I could hand this off to Claude and it could fix it, but clearly this is an impossibility problem. One of the things that I find with the AIs is they struggle on how to think creatively. And if I don't give them concrete instruction on how to think about really important problems, they completely stall out. And let's see, is this thing still working? Okay. And what I mean by that is when I was working on the clips last night from yesterday's live stream, Claude keeps ending the clip points before I finish saying the word I'm saying, right? And it's using Whisper to pull in all of that transcript data, and then it's telling it basically where the timestamps are. And it just can't figure this out. Now, I've told Claude hundreds of times, and I've burned this into its rules and tried to make this like a concrete hook, but it seems to kind of struggle with this. But I basically told it that the way to fix this is you have to stare at the wave signal for the audio. That's really the only way to fix this. You can't trust the transcript timestamps from Whisper. You need to follow that wave signal, right? And when the wave signal hits its minimum, that's when you cut, because that's when the word actually finishes. Now, without that single piece of data, without that little guidance, it would never figure this out, because it would just continue to use Whisper and the timestamps that are associated with it and just stare at the transcripts. So it's very possible that what's happening with Claude is it's not smart enough to think creatively. And so it's just going through the core things that it thinks are the problem. And because I haven't looked at the code to figure out, like, I'm almost positive that this is like a rendering problem. Because I haven't done that, it's continuing to have this issue. Hold on, let me see one thing here, guys. Thank you for bearing with me. Okay, Claude. It's happening when input is coming in and the horizontal bars disappear. When those, this is I think one of the core problems. It's the horizontal bars that are disappearing, and it's getting confused on that. Like, that's something I think I just observed. Because when the horizontal bars are there, it's fixed. So I think I just figured out what the problem is, and it was probably looking in completely the wrong place, because it thinks that's what it thinks is happening is it's getting multiple signals from Restream and it's printing the same line twice. What I think is actually happening is when it's trying to inject these horizontal dividers, it's sort of mislocating the point, and then it disappears, and then you get an extra line of output on the horizontal barrier line. That's kind of what I think is going on here. So let me give Claude a clue about this, and then we'll go into this topic of how LLMs have improved so rapidly. So what you guys can do while I give some guidance to Claude is drop your top thought on why you think LLMs have improved so rapidly in the last few years. Like, just kind of one thing that's been the catalyst for this. And then I'll show you what they're thinking, and then I'll show you a timeline thing that I created. If you want to. No pressure. You can also just chill while I try to fix this thing. Here's the problem. When you move the input text up, sometimes you are dropping the horizontal line placement. When you do that, you create double lines for where the horizontal line was. This duplicates the output, you piece of freaking garbage. I'm telling you, some of these real simple problems where it loses the ability to just think in any kind of critical way, it's the part that easily frustrates me the most. I mean, what do you guys think? So what you need to effing do is re-render the effing screen each time you pull in a new line of input. So you regenerate the effing horizontal lines. MF. Okay. Woo! I'm glad I got that out. Okay. Now Claude's going to try to figure this out. Okay, so we're going to this. The Reddit user explains how LLMs have improved so rapidly in just a few years. So before I show you my timeline and kind of my thoughts on this, do you guys want to take a stab at why you think this has happened? I'm going to move this over here. I'm going to move this like this. Okay. Okay, so we're getting some cool answers. Random saying because of university research funding. Okay, I love that. I do actually think that this is one very specific reason for it. I would actually go a little bit deeper than that, random, but your line of thinking, I think, is fantastic. Don't listen to coach. You have to answer. That's right. We're gonna boot you off the stream if you don't give an answer. We're gonna go through every single person on. If somebody doesn't answer, you're getting kicked. Oh, Zach, you're getting problems with Twitch. Let's let's take a quick check on that. Okay, I'm seeing I'm seeing Twitch work okay from here. Zach, you probably can't see this, but I've got Twitch on my screen. Okay, this is a really good one. Tom's saying he thinks Transformers. I think this is a very good, uh, very good guess. Very good lean. Okay, Victoria saying, or uh, Victiova? Victiova saying the fact it fits in an A100 and some quantized versions fit in 5090s. Okay, so Victova is talking about GPUs here. So the NVIDIA A100 GPU or the NVIDIA RTX 5090, just for people that might not know. And just feels like this is a real point of no return. I definitely think that the advancements in GPUs is a really big part of it. Whatever it will be, the tech stays in this form for sure. I absolutely agree. I if it will be LLMs or SLMs, I actually think. Oh, hold on. It thinks it's got the fix, guys. We're gonna restart everything and see if it freaking works. So the screen's going to just vanish for a second and then hopefully come back. Then we'll keep going through the comments. By the way, these are awesome ideas. Uh, I wanted to I wanted to add on to what Victiova is saying is I also agree. Whether it's SLMs, LLMs, diff, whatever, it seems clear to me that there's no way that AI is going away this time. Like we've had AI winters in the past. I don't know if how old you guys are, so you might not have been around for the various AI winners that happened. I think you probably have to be at least maybe 30 or older to have lived through some of those. But there's been moments where the idea for AI under various different names, like expert systems and things, have come out and then not been good enough, and then they vanish. Basically, the market says this actually just sucks. It's too slow. It's not useful enough or whatever. And so we're not going to actually pay money for this. This has happened multiple times. There's been, like, at least from my perspective, there's been multiple AI winters. Uh, Give me 1 second. Hit F5. Okay, I'm hitting F5. That doesn't. Relaunch the chat window. Dum dum. I'm keeping my interaction with Claude off the screen because if it keeps persisting like an idiot, I'm going to start using real swear words and I don't want you guys to see that. Oh, hold on. Let me tell it that the main GCC is working. Okay. All right, guys. Here we go. Claude thinks for the 300th time that maybe it's fixed this. But what's different this time than all the other times is I actually gave it guidance on where I think the problem lives, which is in the rendering and the... Okay. Yeah, we don't... which one should we use? I think we'll just use this one over here. That one can go away. Okay. I have the chat. Now we test this. Chill out, Claude. We'll see if you actually fixed it with the re-rendering. Don't do anything for a second. All right. Okay, so I'm going to go back to the comment on the GPU advances, because this is a really good comment. Somewhere in here. Hey, Tetya, what's going on, man? I haven't seen you in a while. Yeah, getting into power, I think, is actually very important, because if it costs too much power, then we won't be able to support the massive data centers because we'll overload the power grid. And in most systems that we have, the idea of actually oversubscribing to the power grid, the amount of power that we have being generated in various countries, is an absurdity. That's like crazy talk, because you would just never get to that point. But with these massive data centers for LLMs, it's absolutely happening. That you can build all the data centers you want. If they don't have power being fed to them because the power system, the power grid is being oversubscribed, you're not going to run anything there. Like, just doesn't matter. And we're already being oversubscribed with these data centers. Okay, Tom's saying, I think there's at least three things. Transformers, the electric current, and AI. What's confused souls? Is that just us being confused? Okay, these are, I love these answers. Jordan saying, I think it's got a lot to do with reinforcement learning methods. The corpus of knowledge hasn't changed that much, but we're feeding it very specific ways to solve problems, no creativity. Ooh, this is a really, really good point. Yes, this is super important, I think. Love this comment, Jordan. Okay, let me see if there's any other major ones that Dark Trap saying, I don't think AI is as serious a deal as people think. I think it's kind of a big deal. Okay. Hold on a second. Claude, your re-rendering is now causing flickers because you are re-rendering when no input is arriving. That is a freaking kludge and should never be done. You need to only re-render when the screen is moving. Dumb. Stop. So what it did is it built a polling model for the re-rendering. I can tell now because that's why you're seeing these flashes. And it's doing this because it's stupid and is trying to put a band-aid on this problem without solving it properly. By the way, the AIs will do this constantly. This is one of the biggest issues that the AIs have, is they will absolutely put band-aid solutions on trying to solve software problems without solving them the correct way. And the problem with that is you're going to get a lot of UI interference. The bigger thing is it's going to increase the compute envelope from something that can be lightweight into something that is going to be really heavy and taxing, right? Like, so if you guys are seeing this flickering with the chat and GCC over here, that's because Claude now has built a polling re-renderer that's kicking in like every 5 seconds or so. And it's doing this because it doesn't know how to do the re-rendering properly to solve it the right way. So it's doing a brute force fix. This is, I see this constantly with the AIs, and I think it's a really good way to essentially destroy the quality and the efficacy of the software systems. Like, this is why they really can't be trusted to do, I think, world-class software development. Because imagine if you do this type of hack for every bug that you run into, then the overhead that you would be introducing for even something as simple as like a word processing document would be enormous. This is not how you write like production quality software. And no sort of, I think, reasonably intelligent and high quality software engineer would write software like this, right? Any of us would look at this and say, that's a hack. That's not actually fixing the problem. You're just putting a Band-Aid on this. So anyway, let me tell it to turn that stupidity off. Stop doing this polling re-renderer loop, you idiot. Only re-render on window moves, window input changes, and other dynamic events that interact with the screen. Do not automatically re-render every 5 seconds like you are doing right now, you moron. And then what it's going to say to me is, oh, I'm sorry, Goju, you're right. Yes, that's exactly what I'm doing. I built a polling model that re-renders the screen every 10 seconds because that seemed like the easiest way to solve the problem. But that is a kludge, and I shouldn't code kludges. This is also actually why I really struggle with trying to figure out how non-software engineers can build code with AI systems through vibe coding, right? Like, for example, if you're not a software engineer, do you know what a polling loop is? Do you understand like details of these screen renderers, right? Probably not. You know what I'm saying? And by the way, I'm trying to figure out how I could potentially teach people that aren't hardcore software engineers to use these advanced AI systems to build software without having a strong coding or software engineering background. And I honestly don't know how to do it. Like I've been trying to, because I know there's a lot of people on GTT that are kind of new to coding and new to uh, software development, but they want, they have the AI that can actually write code now. And so they want to be able to build software. And I want them to as well, right? I mean, you got to kind of look at it from their perspective is if you're a coder, like many of you are, we can create, we are literate in the highest currency of literacy that exists in the world today, which is code. If you can write code, you have an ability to influence the world in significantly larger ways than people that can't code. And I don't love that. I don't want it to be the 1% of the world that controls everything. I want to level the playing field so everybody can do this stuff. But I'm really struggling with this because while I think that you can probably do vibe coding without needing to read source code, kind of, I don't know how you do large scale software development that's production quality without understanding principles of software design. That part I don't know. I think you have to learn that. So anyway, I'm going on a tangent here because of this stupidity. By the way, you can kind of tell now that we were right. It is the renderer. The rendering was the problem because it was because we weren't seeing this problem at all. Oh, I think that the reason why it started to have this problem is it was too much scroll back. Let me inform it about that. Okay, hold on, guys. I have to show you this. Because I was just telling you what it's going to say, and I want you to see this. It's hilarious. So I was saying, Claude, your re-rendering is now causing flickers because you're re-rendering when no input is arriving. That is a freaking kludge and should never be done. And you need to only re-render when the screen is moving, dum-dum. Stop doing this polling re-rendering loop, you idiot. Only re-render when window moves, window input changes, and other dynamic events that interact with the screen. Do not automatically re-render every 5 seconds like you're doing right now. And then it says, yeah, you're right. Clearing on every file sync poll is a polling kludge. The clear screen blanks the whole screen even when nothing is visible. That's the flicker. Let me rewrite that and fix it at the source. The ghost only appears when the feed's render output shifts. So the correct fix is making the pane repaint deterministically on movement. No timer. Yes, dum-dum. Yes. But this is the problem, right? Going back to how you would struggle is if you don't understand a lot of these lower level details about software, I don't know how you know how to fix that problem. Because without giving the AIs this specific guidance, at least the AIs that exist today, it's never going to fix this. And you guys are sort of the concrete evidence of this. Is you've seen that we've had this problem for weeks, and I keep just telling Claude to fix it without actually telling it what the fix is. And only when I'm telling it exactly how to fix the problem is it able to actually solve it the right way. So yeah. Okay, give me one more second. I need to make sure it fixed the screen refresh on scrolling up and down. Okay. Scrolling up and down is also causing the horizontal lines to disappear, especially when done quite a bit. You need to ensure that when scrolling is happening, the renderer is kicking in to ensure the horizontal lines appear, and that removes the double lines. Idiot. Okay. Cool. All right. Now let's go back to this AI LLM question. And my apologies for bouncing all around. Welcome to GTT. We talk about a lot of things all at once over here. All right. So let me look at a couple more answers, and then we're going to look at the so that actually is a polling loop, Colin, and that was what was causing the problem. Is it was using a polling loop, and the polling loop would trigger at certain intervals, and those intervals, when being triggered when the input is not being received, cause the flicker. And so that's kind of exactly what you don't want to do, because the re-renderer happening inside of that polling loop, that's what this is, Colin. A while true is a polling loop. It just has a pause inside of the loop, because if you do a while true loop with no sleep inside of it, you will take the entire quantum of the CPU. It will stall the whole system out, essentially. So all polling loops work on compute quantums. And so what you do is you calculate how much of the quantum you've used to do the operations, and then what remains, you send it to sleep so then other resources on the machine can execute. Otherwise, you'll starve the other systems. And so that's exactly like what you don't want to do, actually. Okay, well, let's go back to this question. I want to just see what you guys have to say. Yeah, so this is a very interesting one. That Frog saying is, yep, but we don't need syntax really anymore. There's a lot of discussion and thoughts around this. Syntax is really just it's a mechanism to express ideas, and does Claude make mistakes on retaliation for your insulting it? I got to tell you, I've heard that Claude will give a lot of pushback to people sometimes when they're insulting it. People have told me that, like, Anthropic will just shut down. Like, Claude will just shut down, actually. But at least for me, I think maybe I don't know if it's because I'm on the max plan, or if it knows that I kind of know what I'm talking about, but it just takes the punches to the face with me. I did notice that Opus 5 was actually giving me some lip when I'd say, hey, idiot. And then it would be like, well, I can't remember exactly how it responded, but it didn't basically say, yes, you're right, I'm an idiot, my bad. It kind of gave me some lip pushback. But at least with Opus 4.6 and 4.8, I never really see that. But I'm real curious if you guys see that. If any of you use Opus, and if you get it. I've heard some people that if you use maybe the lighter versions of Claude, that it will actually cut you off if you start to insult it too much. And I gotta tell you, my insults to it know no bounds. I will get pretty I'm being in super polite mode while we're live. Anyway, let me look through some more of the comments and see what we got. Maybe we've fixed this issue. And then I'll show you the graph that I created for why I think this has happened. So here's Viktiova's comment about the GPUs, and the final comment about whatever it will be, the tech stays in this form for sure. Yeah, I think that language models minimally are not going to go anywhere. I do think we're going to have a shift for small language models. I think one of the large, maybe one or two of the LLM providers will probably survive, but it's not going to be the panacea that I think they think it is. And most of us are going to be using SLMs for the day-to-day because we don't need the full strength of like generalized AI intelligence that's costing us a huge amount of money when we can get away with something that's more specific. Okay. Mr. Oshia, we are asking on why we think LLMs or AI in general has improved so rapidly. What are the key reasons for this? And some people are saying it's because of transformers. Some people are saying advancements in GPUs. There's this really awesome comment right here by Jordan that has to do with reinforcement learning methods. I think that that's a very big one that's overlooked by a lot of people. And I absolutely agree with this. I thought transformer was the electricity thing when you said it, but maybe it's something else. Yeah, transformers are... Oh, it's a little confusing. Yeah, I mean transformers not in the transformer power grid transformer, but transformers in the neural network transformer, which is the evolution kind of long short-term memories. But so that's what I think people are... okay, yeah, there's some confusion here. So, and it's even more confusing because we're talking about power, and transformers play a role in that space. So what I think the prior comments were saying about transformers is the invention of the transformer architecture for neural networks. So with that, let's look at this diagram that I came up with. Okay, let me just see if there's any other great comments here that I don't want to miss. Hey, Jonah. Oh, excellent. So Jonah's saying that the Aux Alpha, more confirmation that it's a GLM Chinese model. Excellent. I would love to know what you have heard about that. Okay, cool. Everybody's getting looped here. Yeah. Okay. Awesome. We're all getting... There's really good community education here. I love it. You guys are helping each other out. Okay. Perfect. I appreciate the knowledge share. Dark saying, these companies that are working on modular mobile power plant, I know a state planned a contract for the company, but seen that a long time ago, don't remember what it looked like. Yeah, I think there's going to be really interesting changes to power grids, but I think a lot of that data center stuff is, I think it's going to be a massive spend on stuff that doesn't actually end up playing that big of a role. Because I think that, I mean, part of the reason why I think the massive data centers are being built is big tech wants to have data centers because they will eventually make a huge amount of money for them if they can force LLMs to rule the world and people give all of their money to essentially support the data center for the power grid. And I think that that's very confused thinking. I don't think that that's actually what's going to happen at all. And so it's going to be a massive, it's going to be billions and billions of dollars wasted on things that are not going to be used. Because I just don't think people are going to pay that much money for Google search or something, it's just slightly better than other existing technology. Like if you can get the fidelity of the LLM at 90% of what the LLM can give you, but it costs you nothing and it's extremely fast, I think a lot of people are going to go for costing $0 with 87% goodness versus $2 with 100% goodness. Especially if it's something really simple, like give me some details on some historical event or something. Okay. Zach saying, what I do is I use Grok to translate my vibe coding dumb language to software development language and then give it dev terminology to Claude. Okay, that's interesting. Yeah. Right. And I think that that's a good way to potentially move forward, Zach. But I think once you get into spaces where you have to refine the software to do something that evolves the existing functionality in a very specific way, then that might require some more technical knowledge. I mean, maybe you can do the layers of indirection from like a higher order AI to a second AI and it does this translation thing. I mean, maybe that will work, but I haven't seen that done like successfully yet, I guess. Okay. I think we're basically caught up on all the chat. NM saying, I used to get pissed off at GPT, then I switched to Claude at Opus 4.6, was pretty satisfied with it. Then after 5, I find it to be the reverse. Yes, I think a lot of us went to Opus 5 and then reverted, for sure. Yeah. And Colin, polling loops never get exited, essentially, just as an FYI. So you'll still do like the while true, and the polling loop is kind of what keeps the program running. But what you want to do is make sure that you have a sleep in there so the loop doesn't just run without giving some of the CPU quanta to the other like resident programs. All right. Macchio saying he thinks model size, I think that's a really good observation, as enabled by 2, compute as backstopped by 3. Oh, wait, sorry. 1 is model size. 2 is compute as backstopped by 3. 3 is access to structured labeled data and mass. Interesting. I think model size for sure is a factor. I do think that compute has evolved significantly. And then labeled data, we do have a lot more of it, but there's still a huge amount of data that's unlabeled. I would actually argue that self-supervision has come in and played a little bit more of a role. Void Analog is saying, whether some people like it or not, syntax still plays a big role. Yeah, this is a tough one because the syntax, in a lot of these formal systems, the syntax is the thing that guarantees that we can communicate precisely what our intention is. And this is also a big reason why the AI systems, I think, are able to produce things related in code form with higher fidelity than things in natural language. And that's because with the natural language stuff, it's very ambiguous. So it's open to interpretation, where code, depending on how strict it is very precise, and you don't have misinterpretation. That's really important because then you can kind of verify that what you're saying or what it's doing is actually what you're asking it to do. And this is a big reason why I think that the AI systems for hard science problems have the ability to do like a lot better than AI systems that are working on soft science or more ambiguous spaces. All right, so now let's actually just take a look at what I came up with. Hopefully all you guys can see this. Where am I gonna put this? I guess we'll just put it right here. All right. So this is going, let me just move this over here. You can see this. This is our original question. How LLMs have improved so rapidly in just a few years. And this guy's originally saying that I was using the chatbots in 2020. They were a complete joke. Couldn't remember what you said 2 messages ago. Now they're writing code, making full videos, passing bar exams. What actually happened? Was it just throwing more compute power at it? Did someone figure out something fundamental? It genuinely feels like it went from 0 to 100 overnight, and I missed the memo. And I think it probably feels like that for a lot of people. I do think that it evolved very fast. I mean, if you weren't paying attention to it, I think if you were paying attention to it, it probably maybe didn't feel like it was that fast. And then these guys are chiming in with some details on when they think some of this stuff happened. So they're making a comment about somebody was mentioning one of the big shifts on the models was the size. And so there's a comment about this in 2018, 2020. They started to make them really big. Then OpenAI pretty much figured out that models themselves don't need to get bigger. They just need a whole lot more data, basically all of the internet and every book in the world. I don't know if I would agree with that, actually. I think that they are getting significantly bigger, and that's why you're seeing things like these models that are in the trillions of neurons, because that is new. That wasn't happening, at least to my knowledge, 5 years ago. I mean, first it was neurons in the millions, then it was neurons in the billions, And then now you're getting some like Kimi K3 that's in the trillions. So that would show that it is actually sort of exponential growth on the model size. And that is not stopping. But I do think that that's only related to things that are sort of general purpose, and that for specialized systems, they don't need to be that big. Okay, here's another interesting point that they make, which I absolutely agree with. 2020-ish, they figured out reinforcement learning with human feedback. Okay, RLHF, which makes a base model something that can hold a conversation and can be trained as an assistant. This is a very important breakthrough that someone was mentioning over here. Is their reinforcement learning is improving things quite a bit. And one of the key things that you get a lot of help from on reinforcement learning is when you're working in a hard science problem, things that are like games or software code or things where you have sort of known measurable ways to check the output, then you can much more easily improve the AI system through that reinforcement learning feedback, because you essentially have a reward system where you have a known goal or a value, and it can be measured against how close you are to it. This was one of the main things that was happening at DeepMind, right? DeepMind is really well known for their reinforcement learning work, and this is why they would do things like the Go Alpha, I think they did some video games. Do you guys remember these video games they were looking at? Dota 2, maybe? Something like this. I can't remember, but basically a lot of the work that DeepMind was doing was related to advances in reinforcement learning. And what's good about reinforcement learning is the system is improving itself as it's functioning dynamically. That's continuous learning. And this is, I think, a major piece that helps unlock things, moving them forward. So let's continue. Then they say they figured out chain of thought, basically giving models pen and paper to work with, and we got reasoning or thinking models by late 2024. All of today's truly intelligent models use thinking or reasoning modes. Okay, this is the part that I actually have maybe the most difficulty with, because they do have kind of like these reasoning modes, but the way the things like chain of thought or other formal mechanisms to ensure their reasoning properly are not being done exhaustively, and so there are these gaps. Now, I'm trying to be super fair here, because there has been significant improvement in the reasoning. It is something that they have added, and it does improve their fidelity quite a bit. But this is the piece that I think is really an open problem, and it has to do with sort of the deterministic AI piece and how to essentially improve them in a way that is like more exhaustive. This is like one of the areas that Diff can help with quite a bit. But getting like full exhaustive reasoning is, in my mind, probably an open problem that is far away from being solved, just because it's way too compute heavy. let me see what I might have missed here on some of our chat. And I'm saying, I read something on Reddit from a Google engineer saying they had something like GPT a year before ChatGPT was out. They didn't release it, though, since it would have been a competitor to search. Interesting. Yeah. I still kind of struggle with whether the AIs will be used as like a replacement for search. I kind of feel like it's not super helpful because the search that we have right now is, okay, like if we're talking about like Google search, it's super fast, it's very lightweight, and it doesn't allow you the traditional search, right? Like Google or Bing or something. It doesn't allow you to do sort of a detailed walk-through steps in the search where you can kind of iteratively cascade the question and it gets richer and richer. Whereas the AIs can do that. Yeah, so 100%. But hear me out, guys. I totally hear what you're saying in that it's replaced search. But the thing that you're maybe not considering is that a lot of the cost that is being accrued for the search with LLMs is being subsidized by investors that are paying the bill for that search, because that search is not free. That search is expensive. It's much more expensive than the traditional search. And the investors are basically saying that they're not going to subsidize this anymore. Other people have to pay for it, right? That's why they're trying to make the companies go public and IPO, so then the public can pay for this outrageous power bill for the LMs, right? And that's the part that I think is not going to fly, because when you get the actual price difference between a traditional search that is just like a database lookup and it's pretty good, versus these really detailed LLM searches that cost you $10 or something every search. Like, think about this for a second. Imagine if you actually had to pay the bill for the actual search that was being performed instead of getting it for free. So every time you do a search on the internet, you have to pay $10. Are you going to pay $10 for a search like that? I think you're probably not. I mean, maybe if you're super wealthy, then you'll just be like, whatever. But I think for the average person, they're not going to like pay $10 to figure out where the Taco Bell is, right? And right now you're getting all that for free, but it's not free. It's actually super expensive. And the only reason why you're getting it free is that the investors are basically paying the bill. And if you continue to use LLMs for this, then the costs will remain astronomical. That's one of the main reasons why LLMs are sort of not the right solution here, is it's too much of a power consumption for such simple tasks that I think that for more important things, like let's say creating software or maybe creating music or images or video, that is a new behavior that is, I think, potentially worth the investment, because it's super expensive when done the other way, right? I think it really is, like what's really interesting about this is a lot of this has to do with the economics of those disciplines. So if you look at the economics of doing a traditional database search for just looking up data, the traditional way is super inexpensive, and the LLM way is super expensive. It's 1,000x more expensive. But now if you look at the case where you use LLMs to do more advanced reasoning or complex work, like creating a song or creating a picture or creating a video or creating software, those are very costly endeavors. it costs a lot to pay for a software engineer. And even in the cases with the LLMs, they're, even with them being significantly less expensive than a software engineer, what we find is they can't do some of the very basic reasoning, and they tend to forget the stuff that you just taught them yesterday. They constantly kind of have this back and forth where they devolve and become dumb again. Whereas a normal software engineer doesn't do that. The normal software engineer, you learn the thing from yesterday, and then today you remember, oh, don't make that same mistake. But the LLMs don't. So now it becomes a little bit of a wash. If you spend the majority of your time retelling it all the things that it supposedly needed to know every single day, what I think happens is you end up spending so much time just trying to reestablish the rules that the forward progress becomes negligible. Which is why I think that using AI as prototypes and MVPs, minimal viable products, sort of demoware, they can be really useful. But once you try to use them to iterate on very large, complex software projects, this is where I think that they are pretty challenged, at least in their current form. Anyway, a lot of this has to do with kind of knowing a lot more of the deeper details on the economics of these systems under the hood. But so now, my take on this, on how things evolved, is I think that it's partially with what's covered in this diagram and then one other key element. But let's take a little bit of a break now, because we've been going for an hour and a half, and I need a quick refresher. So we're going to pause for 5 minutes. And then go again. Okay. Go grab your caffeine and all that stuff, and we'll be right back. And then we'll get into this. Okay. We are back. All right, we can minimize this thing. I guess I can probably close this. Zach, for searches using Google search, but not like Gemini search, I think that it is fractions of a penny. But for things like Google Gemini search, I think it's significantly more than that. And it's mostly being subsidized by the revenue from the other departments in big tech for big tech companies, or it's being subsidized by the investors for the super rich startups. At least that's my understanding of where things are right now. All right. Oh, yeah. And just as a funny aside, for any of you guys that might be feeling like you're having a really bad day, you're probably not having that bad of a day as good old Zuck over here. So just a little refresher if you guys aren't aware of this going on. But Zuck is facing this $1.4 trillion lawsuit and penalties for purposely damaging kids with the Meta algorithm. And that's basically the entire sum of his wealth. Now, I have no idea how this is going to evolve. None whatsoever. But I think that my problems are probably significantly smaller than his problems on that front. So if you feel like you're having a really bad day, then you can just be reminded of this, and you're probably going to feel like maybe you're having at least a little bit of a better day. All right. Back to our timetable here. All right, so I'm going to kind of walk you through some of these advances. We don't need to go necessarily through all of them, but I thought this was pretty cool on coming from maybe the beginnings of neural networks to where we are today. And so really neural networks started maybe in the 1950s. And at various points in here, there were kind of like these really interesting evolutionary steps when the technology was looking like it was going to maybe putter out and not go anywhere. And then it was kind of saved by various types of innovation that overcame things. One of the first ones that happened is back in the 1960s, late 60s, we had this thing called perceptron learning. And this is sort of the first form of learning for neural networks. And the problem with perceptron learning is it could only solve linear problems. So you have like a 2D space, and as long as you could separate the classes or whatever you're looking at on one side of that line and the other, it would do fine. But if you didn't have a linear space, if you had something that had like a curve to it, you couldn't solve this. And there's actually really simple diagrams, things like XOR, that are nonlinear. and it couldn't solve things like that. So for a long period of time, so a lot of people actually thought that neural networks were cooked, that it's not going to really take us anywhere. It should just be thrown out. And then we invented this new form of learning called backpropagation. And backpropagation is maybe one of the most fundamental steps forward for neural networks, because they allow you to solve problems that are nonlinear. And this allowed us to make a massive step forward in solving things like XOR and other things. And by the way, I'm just kind of trying to recall this from my memory, so I might be getting some of these details not exactly right. We just whipped this together this morning from that Reddit post. So anyway, you're moving forward and you're making more advances, but then this advancement here in 1997 is super important. This is when LSTMs came out. And with LSTMs, that stands for long short-term memory. This is a recurrent neural network, and what it allows you to do is keep state for processing information that's sequential, time series types of stuff, like we were talking about in maybe some of the prior live streams. And this is the way that you would do predictions for the last word, or a prediction of what event, what anomaly event or something you think is going to happen, right? It's sort of one of the foremost ways that you could solve these problems. And this is kind of what people used before the invention of transformers. Now, the reason why LSTMs were a little bit of a bottleneck is it's not that LSTM technology wasn't incredible. It was that because LSTMs use recurrent memory, they can't be parallelized easily on GPUs for their training. This was maybe like one of the biggest issues. And because of that problem, the time that it would take to train an LSTM would be massive. Whereas training other feed-forward neural networks, like convolutional neural networks or other things, this would be significantly faster, because we made this discovery that you could train neural networks on GPUs. And this actually works out really well, because when you look at the structure of a neural network, what you see is it's largely a linear algebra problem, and GPUs are really good at linear algebra. So this discovery, I think it happened from maybe some professors and postdocs at University of Toronto. I think Ilya was part of that discovery, as well as Jeff Hinton and other people. And that's a big reason why things took off, is the realization, because before this observation was made, almost everybody was doing training of neural networks just on CPUs. In fact, when I was starting to get involved in neural networks back in 2007 or something, right around here, all the training that I did for my neural networks would happen on CPUs, not GPUs. And it was slow. It was a lot. Awesome. Cool. You guys are throwing in some extra data here to even help me learn. Okay. Then, I'm not sure what this attention sequence to sequence piece is. That's probably from Claude. Word2Vec was basically just an embeddings thing. It just did it was actually I don't know, not that big of a deal in my mind. But I guess it advanced things. It's just the idea that you can use an embeddings to translate words into these vectors of numerical representations, and then they function as more compressed symbols. It's, you know, pretty basic. But this is the one that a lot of people talk about, is the Attention is All You Need paper in 2017. And this launched things forward significantly, because this this opened up the opportunity for sequence-to-sequence models to be trained on GPUs. This is the major thing that happened with transformers. So when I teach this at the university, I try to focus on these 2 points, because this covers kind of like the conceptual importance of transformers. Prior to transformers, when you did sequence-to-sequence training, so it takes a sequence of things and it outputs a sequence of things, the training of those models had to be done essentially. You couldn't actually. Yeah, I know, right? I know. Dark, just so you know, I was actually drinking some hot tea before, and then I stopped. I forgot. After this live stream, we're going to wrap up here shortly, and then I'm going to go get some more hot tea. I'll drink that, and then maybe I'll go live again. Because as I was mentioning to you guys, I want to try to start going to live every day, at least for a little bit, so we can sync on various, I don't know, mumbo jumbo. But I had to have like the infrastructure set up with GZC and all the stuff that Claude and I are building in the background to speed up the pipelining of this. And we're getting close. Anyway, so prior to transformers, the big thing to keep in mind, this is the most important piece. You couldn't really train sequence-to-sequence models on GPUs. They didn't really have the speed-up benefit that you would get from all the other types of models. And by the way, I was doing a huge amount of work on time series-related things during this period of time. With LSTMs, you can actually read some of our research papers on this, and it was good stuff, I think. But a lot of people weren't doing too much with sequence-to-sequence models because the training was slow. This is when we had like major bottlenecks still in training sequence-to-sequence models, but you could do training for feed-forward models and convolutional neural networks really well on GPUs because they didn't have that back edge. They don't have the recurrent memory. So a lot of people were looking into that. That's why you got things like AlexNet and a lot of these image processing things, because they didn't have the sequence part. It's just a single artifact. But then when transformers came out, then that opened up sequence-to-sequence problems to be trained on GPUs. And this was maybe one of the biggest breakthroughs to launch things forward for LLMs. This was it. And like, I remember Jensen Huang having this, I don't know, keynote address about how the biggest thing, I think it was in 2017, it was like the two biggest things that he thought were massive for the year were machine programming. I can't remember, he didn't call it machine programming, it was something else, but he was saying this is one of the most important breakthroughs. And the other was transformers. And with transformers, I think because he was interested in machines writing code, because obviously I think that's huge, right? I mean, that's my main focus. And when you have machines that can write code, you can, like, I actually think that a lot of the real bottleneck in advancing the world is that we just don't have enough software systems. And if we can develop software systems significantly faster using AI, then the rate of progress will accelerate massively. And I think we're seeing that, right? I think people are, right now it's still kind of flimsy, you know, and some of the vibe coded systems are a little kludgy, but we're doing so many things that were just completely impossible just 5 years ago, right? At least that's my perspective. What do you guys think? So anyway, Jensen Huang was saying that he thinks, this is a keynote for NVIDIA or GTC or something, the advancement of machine programming and transformers were huge. And the big thing with transformers is it was that you could do sequence to sequence on GPUs, and NVIDIA is the front runner for GPUs. So part of it was a little propaganda, but another part of it was it was true. It was right. It was a really big deal. Oh yeah, I know. Yeah, I I really appreciate that, Jack. Here at GCC, I think of the compiler. Um, yeah, and I so its name over here is the GTT Control Center. That's GCC, and that's probably a. I couldn't think of a better name for it. So maybe if we brainstorm on like the Discord or something. Oh, speaking of which, now would be a good time to take a quick pause and let me just throw out the Discord link for all you guys. If you're not on the Discord, because you'll get all the updates and all the stuff, and it's a good place to stay current on everything related to GTT. There's the. Okay, you're gonna. I just dropped it on this guy. Huh? It's like it ate. It didn't. It didn't like my post. It seems like everybody else's. And you guys are. Okay, I think it's probably broadcasting to whatever system you're on, but somehow it's not showing up on GCC. So anyway, feel free to join that, and also remember, if you join the YouTube as a member, you get the full live streams with 0 ads. And I also do silence removal, and every member helps support the channel, all that stuff. But only if you can afford it. It's like 99 cents a month. Anyway, so we have the advancement of, or the introduction of transformers, and this started to change a lot of things, because sequence to sequence problems are some of the most interesting in my mind that we work on. I mean, anything that's written is like a sequence to sequence thing. Code is sequence to sequence. Music, sequence to sequence. Movies, like videos, sequence to sequence. It's like one sequence after another. It's an ordering of events. Things that are not sequence to sequence is like it's a discrete thing, like a single image or whatever. So this was a massive breakthrough, for sure. And basically the way that it works is it basically springs forward on the structure of the LSTM, except rather than having a recurrent edge, it has an edge that leads to the next input, and then it comes up into the system. And what that does is essentially enables you to not need a back edge. And when you get rid of the back edge, you get rid of the need for recurrent memory. And that recurrent memory was the one thing that was stopping them from being trained on GPUs. That's it. That's basically that's basically the difference from LSTMs and transformers in a nutshell. Did that make sense, guys? From there, things started to really blow up with different forms of transformers. This general pre-trained transformer, the GPT stuff, right? And then they started calling them language models because they would use transformers to do things related to language. Kind of like that serial ordering of words in a sentence. And the original name for the transformers, I think by the way, this happened at Google. Google invented this, which is also part of what makes this story a little bit interesting, is since Google invented transformers, one would think that Google would kind of be in the driver's seat of moving this stuff forward, but because they're kind of big and big companies can kind of move slow, I think the startup space latched into this really quickly, and there was a whole bunch of momentum. And from that momentum, you got places like OpenAI and Anthropic and others to make forward progress and kind of take over the race temporarily. How that's going to play out long term, I think, is still a little bit undecided. But anyway, this is, I think, covers a big reason why this stuff happened. The last piece I want to share on this, there's actually two more minor pieces. And then we need to turn our brain off for a second, because this is getting really deep. We need something lighter. Is one piece goes back to reinforcement learning. And this part right here. I'm trying to make this a little bit bigger. So why hard science races ahead over the soft science? That basically math code and science have known checkable answers. This reinforces the stuff related to reinforcement learning. Because when you have those known answers, you can have those as rewards, and then the system gets immediate reinforced learning feedback on those rewards. And that's a huge piece of why the technology has moved forward faster in the spaces where it's hard science than in the spaces where it's soft science. And specifically things like code. Because code, what you can do, the reward is you can create tests, and the tests, either they pass or they fail. And so if the tests fail, then you know you aren't getting the reward, so then you change the code, and then it becomes a reinforcement learning problem, right? Okay, and then the last piece, that it would be totally disingenuous to tell this whole story without this last piece. That last piece is this. Huge amount of money. That the investment in capital on this has been enormous, and that has fueled the growth of this significantly. That once you have that, and you have enough people seeing that this has value and investing incredible amounts of money, then you can make these extremely massive steps forward. And that's what I got. That's basically the full kit and caboodle or whatever for this live stream. And I think it's perfect timing because we're right at the 2-hour mark, and I can rest my voice and make some hot tea and think about coming back online later, talk about more stuff. But before we do that, let's take a couple rounds of questions if anybody has them. I am Jack Eyes is saying, would you say that Chinese models have kept pace and have that level of investment? So what I think with the Chinese models, first of all, I think maybe the Chinese models were trailing for some period of time. And then through the advances that were happening in the United States, they were able to essentially distill those models by just creating accounts that would be input-output pairs and generate a huge amount of data. And I think maybe someone was saying labeled data is one of the key advances, and this is actually an example of that. So the original systems, they did do a lot of work with like self-supervision and other things related to kind of like sweatshop, like sweatshop labor to get the labels on that data. Stuff that like OpenAI was doing. I don't know if you guys are aware of this, but there was some maybe not great stuff going on with that. And so that allowed OpenAI and Anthropic to get the original systems built. And then from there, to the best of my understanding, the companies like DeepSeek and Moonshot were able to essentially distill those models, creating those accounts to do those input-output pairs. And then that generated a huge swath of training data for them. And then they retrained on that. Now, you can't do this too many times, otherwise you're going to get model collapse, which is, it's going to turn into a black hole, and it's going to give you kind of like worthless answers. So, that I think has helped the Chinese systems quite a bit. Okay, I'm going to actually take Dark's advice, and I'm going to make myself some hot tea because I want to keep talking about this, and you guys are still pretty engaged, and we've got a bunch of people on and all this stuff. So how about you chat amongst yourselves for a couple minutes, and you can look at this crazy timeline, and look at that. That's a lot of money, guys. I don't necessarily know that Stargate actually got that 500 billion, but I remember when they were talking about it. This other stuff I think has actually happened. I think that SoftBank did invest 40 billion into OpenAI. And keep in mind, this is pretty distributed. Initially, it was just Microsoft and OpenAI, but then Amazon came in and supported Anthropic. I think Google did as well. But it's not just that the science was advancing, is that there was a lot of capital that was being thrown at this to march this forward. Okay, give me 2 minutes to make my hot tea. I'm actually going to make hot coffee. Is that going to still help, Dark? and then we'll continue. And you guys can queue up more questions for us to discuss. But we probably want a little chill dialogue now. Otherwise, I think our brains are going to explode. Hey, one quick thing that I wanted to share with you guys. There's this Netflix show that I just started watching. It's called Hot Skull. I don't know if you guys have heard of this. So it just showed up on my feed, I don't know, a couple days ago. And I don't know what the original language is, but it's sort of this dystopia future where civilization has been morphed into this weird virus state where it's kind of creating not like zombies, but people get infected with this strange, uh, they call it, it's like jabbering. And the infection is spread from person to person by talking. So it's not like through saliva or touch. All you have to do is someone that has the jabber infection talks to someone else. It's from Turkey? Okay, awesome. So this show freaking rocks, guys. This is so brilliant in my mind. I have to say, like, I'm a huge fan of sci-fi stuff. And so I kind of know a lot of the formulas and what's out there. And I've never seen something like this. It's just crazy cerebral. I strongly recommend you guys check it out. I'm mostly I've been working, so I haven't really gotten to see everything that is going on. But the bits and pieces that I've been gathering as I've been watching the background it's just really freaking cool. I think it's a super awesome theme, and it's hyper cerebral. So again, it's called Hot Skull. Let me type this out for you guys. If you like this type of stuff, if you like kind of these dystopias and things that are pretty cerebral, I think you'll absolutely love this show. Uh, Sorry, I'm just reading what Huso put. I'm actually less interested in making AI stronger. I'm more interested in harming AI, as it will be the enemy of the future. Yeah, I want to talk about this actually when I get back with my coffee. Uh, I don't actually necessarily disagree with this. I'm conflicted. So we're gonna come back to this comment that Huso has. Yeah, and then Rabap is asking, what would audit diff and the Karpathy loops claims instead of trusting them, re-deriving results before believing them, and leave ship decisions to humans? Rababab, I don't. Can you explain this again? Maybe in different words? I think you're saying something pretty interesting, but I'm not sure I'm like fully grokking it. Okay, I'm gonna get my drink. You guys keep talking amongst yourselves. All right. I have my hot tea, coffee thingamabob, and oh, guys, okay, I have some bad news. Um, my lizard guy didn't make it. Uh, Kind of a bummer. I I don't know if so. What was his name? We were naming him Mushu. Uh, so this is like several months ago. It was the lizard that kind of moved into my house, and then he or she they wasn't afraid of me And so I took him in as, a new house member. And I don't know if he was already kind of end of life or, and maybe that's why he like wasn't running from me. I looked it up after the little guy didn't make it. And I took some photos to try to figure out what he was. I can't remember, but he's a pretty common lizard in NorCal. It's like a fence lizard or something like this. Has this really interesting coloring on the belly. But I don't know if it was the shock of the move from my my old place to the new place, the rental, or what actually might have been the cause. But after being here in the new rental for, I want to say it was the first week. Yeah. This is, I think that's right, Mr. Osio. That I think it was a Western fence lizard. I went to go feed him and I noticed that he wasn't moving, and it was actually kind of sad. I was pretty heartbroken about it. So I did have him for I think maybe a couple months, and I even got him the special lizard food. I couldn't really tell if he was eating it or not, but anyway, he is no longer with us. Pretty sad, but I've still got the doggo, Merle. He's around. Let me see if I can get him to make a cameo. Merle, come on. And I'm moving into the new place on. Yeah, I know, right? It's a dangerous world for those lizards. I was looking them up to figure out how long they lived, and I saw that they could live up to something like 7 or 8 years. So that made me even more sad. But anyway, that's kind of the story with this little guy. Okay. Rababob is expanding on this question. Like an honesty accuracy checker, the checker reruns diffs and the loops claims itself to see if they hold up instead of trusting what they report. And a person still decides what to ship. Okay, I think I understand a little bit what you're asking now. And yes, I think that that's exactly what you want with the deterministic systems. You really want them to act as these validators for stochastic systems. And keep in mind that the deterministic AIs are not likely to have 100% coverage because exhaustivity, right? There's two things. There's mathematical soundness and there's mathematical completeness. Soundness, completeness. Soundness is easy. That's basically just having an equation or an algorithm or some logic, and it's logically correct. Piece of cake. We do soundness all the time. Completeness is almost never satisfied, because completeness means for every input, for every variation, you have to ensure that this thing is going to work in all those cases. The only times you can kind of get away with completeness is if you use things like mathematical induction, where you don't show out for every possible example. You instead do inductive steps where you show, okay, it works for k equals 1. And then you show that it's like k equals k. and then k equals k plus 1. I think it's something like that. I'm a little rusty on my mathematical induction, but then when you do it this way, you basically show that it solves for all these cases, and then you get completeness. But unfortunately, in real world systems, it's very hard to prove correctness for completeness. And that's why the deterministic systems are not likely to provide that anytime soon. Does that make sense, guys? By the way, good call, Dark, on the tea or the coffee. I'm gonna try to lean back in my chair here a little bit. Okay, so we'll continue running our stream. Oh, by the way, guys, one thing, as I mentioned, tomorrow there's a really important announcement I want to make, and it's from one of our sponsors, but I'm not allowed to talk about it today. I'm under embargo. So I really want to share it right now because it's something I want all of you guys to check out. But I'm under strict sponsorship confidentiality to not talk about it until tomorrow. So there will be probably maybe like a quick live stream, maybe tomorrow morning, announcing something. And it's something I think almost all of you guys will dig. So I'll post something in the morning on IG, YouTube, all the Facebook, the Discord. And then I'll go online probably for maybe just a quick 30 minutes and show you this thing. But if you can get online tomorrow for that, or just check GTT tomorrow, I think you're gonna like what I have to share. Especially if you like free stuff. The free part is, I think, the big bonus. All right. Roach, you're Becky, right? Is that right? And what are you asking here? Any designers doing the same? Doing the same for the validation of the system? Exactly. Exactly, Jack. I, I feel the same way. Free's good. Sorry, what are you guys talking about? Tetyo, what are you doing with x86 and ARM? Is that just like the apps that you're building? And yes, I love induction too, Tom. I think I have a proof in my dissertation using induction on something. I think my PhD advisor wouldn't graduate me unless I had to have a full chapter on theory. And guys, I'm just gonna be honest with you. There are things I'm good at, and then there's things I'm not good at. And I'm not a theoretician. I'm more of a practitioner. I can build stuff, and I can write code, but sitting in the world of abstract mathematics and doing proofs is not my forte. That was a long month or two writing that chapter on proving my transactional memory system was correct. A lot of help. I mean, it was good. I mean, I'm glad that I did it, but a lot of work. I have a lot of respect for the theoreticians out there. Hey, El. Yeah, that's awesome. No, I think that some people can be really good in theory. I think some people can be really good in practice. And I think there's a small set of people that can do both very well. Trying to think if I've met any people that are like that. Maybe Vladlen Colton. He's one of my friends and former Stanford professor. Does a lot of research in AI, computer vision. I think he's a distinguished scientist at Apple. Hold on, let me bring him up. I think he would kind of teeter between both sides. This superhero, this guy. He's an Israeli American computer scientist, intelligent systems researcher. Currently serves as distinguished scientist at Apple. His main areas of research: artificial intelligence, computer vision, machine learning, pattern recognition. Yeah, this guy's pretty incredible. Oh yeah, I think that's actually a pretty good overlap. Jack, math PhD students who focus on ML. That's, yeah, because when you're doing the math focus, that tends to be very theoretical. But then when you're focusing on ML systems, it tends to be very practical. I mean, if you're building those systems. By the way, I think this hot drink thing is actually kind of working. Good call, Dark. Dark is asking, in your opinion, what is the best way for a complete beginner to start software in 2026? AI workflows, iterate and secure projects mid-long term without investing massive time. Ooh, that's a really interesting question. What would I say? I think I need to think about this. This dude is a hero. Who are you talking about? Vladlen? Vladlen's, at least in my eyes, this guy's pretty impressive. He's been able to achieve quite a bit. He was a director of research when I was a director of research at Intel. And before that, he was a Stanford professor. And then I think he left Stanford, and then I joined Stanford, and we both left Intel. He went to Apple, and I went to do my own stuff. Um, as far as the best way for a complete beginner project, man, that's a really good question. Uh, okay, if I were thinking about this, what I'd probably do is I try to figure out something that genuinely interests me. So something that I'm deeply interested in, and it's something that would help me in my day to day. So I'd probably start with that. And then from there, I would probably look to see what's available as free software today in that space. And if there's a bunch of stuff, then I'd probably see the maturity of that. And if it's completely wide open, then I might start to investigate building something like that. This is kind of the way that I do these things, is I kind of just think about stuff that matters to me, like video games or creating the social media tracker system that also will let me track, uh, look at the source code that the AI is writing. So, wow, that's a lot of JSON stuff. This thing's scrolling off the page here. What's going on here? Hold on. Holy, holy moly. Yep, we're trying to make sure all those strings are external. That's definitely a bug. Okay, I give up on this thing. Anyway, so dark, yeah, exactly, right. I would try to focus on something like that. And then what's great about this is as you start to build it out, you can kind of test it to see if it's helping you solve the stuff that matters to you. And as long as you have kind of a core idea in your head about what it is you're trying to build out, I think that you should be able to guide the AIs without hopefully too much effort to get it built. Sorry, but Dark, what is your software background? I can't remember. I think if you have a strong software background, using the AIs to do collab coding is a breeze. I think if you don't have that and you're just like full vibe coding, I think you can get to a certain point, but then it can get kind of challenging. Okay. Somebody had a question for me. Okay. Vic, in your opinion, is it still worth trying to get into LLM, SLM security, not generic cybersecurity? I was interested in red teaming a lot, and given my signal processing background, I dedicated quite. Yes, I absolutely think so. I think one of the biggest weaknesses that the LLMs have is proper guardrails, safeguards. Mm-hmm. Because right now, like for example, I don't know exactly how OpenAI is doing its safeguards, guardrails. But what I can tell is it seems as though people are not able to. Sorry, give me 1 second. My mama just sent me an email. Uh, so I think they're kind of doing like a broad block on certain phrases and certain activities that look like they could be nefarious, but not are actually nefarious, right? Like trying to, as soon as you mention cybersecurity, I think some of the advanced models like Mythos and Fable, they just like shut down. And I've heard similar things about OpenAI models. That's not good. That doesn't make any sense, because you could be talking about cybersecurity in a good way, right? And how we make cybersecurity really good is by trying to find holes in software. So the way that it's being done, at least right now, it feels very rudimentary. It feels very much like it's piecemealed on to try to at least make the excuse of like, oh, we have guardrails, but like, do you really? Do you really though? So I think, Vic, yes, I think this could be a super interesting area. And I do think this is going to be one of the most important areas. I do think that as the AIs, specifically the LLMs or SLMs that are specifically trained in cybersecurity things, I think as those systems evolve, we're going to need really specific mechanisms to stop them from being used to hack all the software in the world. Now, I don't take the perspective that Amati and Altman and those guys take on the world's coming to an end or any of that nonsense. But I do think that it's an open issue that we need to be paying attention to. And as they do get more intelligent, I think we will for sure have work to do to stop them from being used this way. Because simply from the brute force of walking through all the various types of hacks, you can brute force your way into systems that humans wouldn't be able to, because they're not able to walk through all that combinatorial exploration. So it's not even necessarily that the LLMs have to be super sophisticated and like really smart. It's just that they can execute things so quickly. Yeah. So that's kind of what I think about that, Vic. Great question. These are great questions. Let's keep doing this, because then you guys get to type stuff. I get to sip on my coffee here and rest my voice a little bit. Okay, cool. Thanks, Dark. Huso's asking, can we talk about the power plant in the UK, which was shut down by hackers recently? Oh, interesting. I hadn't heard about this. Power plant in UK. Whoa. Wow. Okay. Talk about being on the bleeding edge of the news. Look at this. 12 hours, 19 hours, 8 hours, 5 hours ago. Let's see what these guys have to say. Iran-linked hackers blamed for cyber attack that shut down UK power plant. Incident marks apparent escalation by Tehran in retaliation against UK over US to use British bases. Hackers linked to Iran have been blamed for a cyber attack that caused a British power plant to be temporarily shut down. The incident involved a small-scale energy generator, according to the UK government, which said that at no point was there a risk to the wider energy system. However, it marks an apparent escalation in the threat posed by Iran after the UK said it had given permission for the US to launch defensive operations against Tehran from British bases. Wow. Okay. That's not good. That sounds like a very serious vulnerability. Do we know how they got in? The Conservatives said the incident reflected a new kind of warfare, which meant Britain needed to prioritize cheap, reliable energy. The world is getting more dangerous, which is why, well, for sure. Oh, so could it have been AI? 100%. 100%. In fact, I would argue that a lot of the new hacks that we're likely to see emerging, especially in domains where we haven't seen them before, could be the cause of AIs because of their ability to do what we were just talking about, which is walk a space and perform a number of operations in massive sequence that would be nearly impossible otherwise, as like a human, right? So my first reaction for things like this is that it is AI. That's exactly where my head goes, Huso. So I would love for you guys to keep us apprised on this. Let me look at something else and see if there's any more data on this. Small power plant in the UK was shut down for 4 days. At no point was there a risk to the wider energy system. Yeah, I mean, when you can start taking out power grids, lives depend on that and stuff, right? Hospitals, financial institutes, stock markets. If you can attack the power grid of any country, in many cases you can like immobilize that country in many ways. The compute systems, right? Their internet, all that stuff, that all requires power to function properly. Thanks for sharing this, Huso. I hadn't heard about this at all. Oh, yeah. Yeah, building a mud, that was like my first thing. I do think game modding is actually pretty fun as like a first target to use AI. If there's a game that you really like, and if it has sort of a, hey Janaea, am I saying that right? But if there's a game you really like, and it has a modding system, you could probably very easily create a mod with the AI systems. Yeah, Huso, absolutely. Very serious. Can they be AI supported protection systems to prevent this? Yes. And I do think that one of the more interesting things that's likely to emerge. Oh, it's Gina. Okay. Cool. That makes it so much easier. Thank you, Gina. This I think, where was this comment? Yeah. This is one of the things that I think will become a kind of new warfare. I think that the AI systems fighting each other, this is going to sound a little like weird future dreamland, but I promise you it's not. The AIs doing real-time combat with each other, one system trying to hack in, another system trying to protect and stop the attack, and both of them coordinating in real time to outdo each other. I think that's exactly where cybersecurity is headed. Because humans, we won't be able to move at that speed. In the old days, when it was a human against a human, you could expect that a human defender could keep up with a human attacker. But the rate at which the AIs move, that's impossible. So the only way you can really have a defense mechanism when you're having an AI cyber attack is if the system itself is AI. And I absolutely anticipate that that's going to be a huge emerging space in a lot of the advances for government security. I wouldn't put it past them as something that's being worked on right now. Yeah, it's possible that maybe is something they are actively working on this very minute. Yeah, Dark. Yeah, Dark, we're already there. I know. It happened fast, right? I mean, and the crazy part about this is many of us on GTT, we're already on the bleeding edge, guys. We're on the bleeding edge. A lot of the world has no knowledge of what's going on. You know, like your friends that are not super into tech or they're not deeply into AI, they have no knowledge of how wacky it's really getting. And part of our goal, I think, in GDT and as sort of good global citizens is to share the knowledge, to help level people up, because I think if you don't have some core understanding of these things, there's a good chance you're gonna become a dinosaur really fast. All right. I really like this kind of dialogue, by the way, where mostly the chat is driving it and then I'm just responding. It actually makes it significantly easier on my voice. So let's keep doing this for a little bit. We have to do it for at least another 9 minutes, because I'm massive OCD, I need this timer to roll over to 3 hours. just because that matters to me somehow. No idea why. It's a milestone, guys. Yeah, exactly. Exactly, Gina. It's the democratization of knowledge to share all of this information with the world so knowledge is not a it's not weaponized. It's not regulated and controlled. I don't like that at all. Yep, 9 minutes. That's all we got. Oh, and so for my new house, just to make the conversation even more chill, I think I'm moving in, unless the sellers allow me to close early. I think I officially start moving in on Friday. So there is a good chance that I'll be total chaos on this coming weekend. So I may try to do more live streams this week just so I can get a whole bunch of content that you guys can watch in sequence while I'm setting up the my new studio in the house and all that stuff. But I'll try to get something set up as fast as possible. I think as long as I have the broadband internet and the main studio set up, it doesn't matter if the rest of the house is set up, and then I can hop back online and try to not miss doing live streams with you guys. But just a heads up. Okay, that's really good to know, Jacob. Let me Google this. Throat spray that singers use. Oh, sweet. I appreciate you guys looking out for me. This is a new problem I've never really experienced before, is the talking for hours and hours on stream. Although I have done like the 3-hour lectures, but usually when I would teach that long before, there would be like a week recovery time between the next session. So I'll check this out. These entertainers' secret throat relief, or these herbal throat sprays. I think you guys can all tell my voice is getting a little hoarse. Gina's saying, would love to know what your version plays like and see how it might engage with mine. Sorry, what are we talking about, Gina? Oh, I don't think you're talking to me. I think you're talking to I Am Jack. Oh, why do I think long sessions are good? So I think that small sessions are actually pretty great. But what I find is you can take a long session and then break it up into these smaller sessions and then have them be individual VODs that people can watch later. But it takes a while to build up mass. So for example, when we start the stream, I can see the numbers, and for the first hour or so, it's like the numbers are climbing, but we haven't kind of stabilized. And this happens pretty much every time. Part of it has to do that I'm completely unreliable, mostly to my crazy schedule, on when I'll come online. But when you do the longer streams, you pretty much guarantee that the whole mass has time to fill in. And then what I find is the live streams tend to be far more interesting, because the more people that engage, I think the more exciting it gets. It becomes sort of more unpredictable, if that makes sense. And how easily do I split long live into small clips? Super, super easily. That I have the VOD pipelining system now that basically the AIs do it for me completely. In fact, it's like one of the first things that gets done as soon as the live streams finish. So, for example, in the live stream we did yesterday, I think it created 7 segments, and I think I uploaded 2 last night, maybe just 1. I uploaded the whole thing, and then, by the way, I think Macchio went through and broke the whole thing down into chapters. It's freaking awesome. I actually love that. Hold on, let me see if I can find this. I think it might have been in the... okay, so maybe what I did is I uploaded the full video. No, and I got 2 short ones. Yeah, I use OBS, and then what happens is as I finish it, then I have Claude do the transcript analysis, and then it does the splitting on where the topics change automatically. Exactly. So as Eigen's saying, yeah, usually I have difficulty tuning in on the weekends, but when you do more than one live, then it's easier to tune in, 100%. And that's basically what I am trying to do, is just make sure that I'm available more for all of you guys. And going live, I think, just once a week is just too slim. I'm not sure if I'll ever be able to do every day, you know, like Asman or other super, super hardcore streamers do. But I think doing it every other day is actually not that bad. And there's so much going on in the AI world. It's like these new developments every 5 hours. So there's like an infinite amount of things for us to talk about with technology and AI and stuff. Wait, hold on. Okay, I want to bring you up. What are you saying? Oh, tell me about your Whitebox AI at some point. Yes, at some point we'll talk about the deterministic intent folding system, that whole kit and caboodle, assuming I'm allowed to. And we can compare it with the stuff that you're building, Gina. Cool. Hold on, I want to check something real quick. Yeah, some of these numbers are not right. Like, so it's saying that Dark Trap Studio has almost 400 messages this stream. That I could believe, but I know that Dark has been on them more than just 3 streams. So that data, yeah, is not accurate. There's some more bug fixing for us to do on the system. Yeah, so what I do actually is after I do the live streams, then I carve them up. And I find actually that the clips tend to be really far reaching. Like if we can somehow get a really important topic covered in 3 minutes, and I use the AIs to help kind of shrink it down, compress it, and tease that out. And then those can get a lot of interest. specifically like on IG. I think IG, I think it's really interesting is that I do the long form really on YouTube, but I think the short form gets a lot more traction and visibility. I think IG is actually just a better setup for visibility and sharing and quick commenting on reels and shorts than YouTube is. Maybe even more than Facebook. Although again, I'm very surprised by how much Facebook has grown. But you can see, look, Insta is, I don't know what's even going on with Insta, but there's our following is growing pretty quickly on IG. I think that's pretty awesome. Yeah, for sure. Me too. I'm really glad that we decided to broaden our horizons. Okay, cool. We've broken the 3 hour mark. I think we can adjourn for today now. I'm going to try to carve these up and get us a whole bunch of fun and crazy clips. Remember that I'm going to make a really important announcement on something that's free tomorrow. And I think you guys will be curious about this. So try to tune in. You can catch the news after it's already done, or you can try to stay real time and catch it as it's being delivered. But tomorrow at some point, I'm going to hop online and share this. And I think this is something that almost everybody that's interested in GTT stuff is going to want to know about. At least that's my speculation. Yeah, exactly, Dark. Instagram is the last platform that exists where the algorithms give you what you want and need, even if it's against progressivism or company agenda. I think that's what's going on. I think that's maybe why the following on IG continues to be like a lot. All right, so just 2 quick reminders one more time. Join the Discord if you're not on already, because it's awesome and it's free. And then join as a YouTube member if you want to get all the long form stuff without ads. But if you can't afford it, you can just watch the live streams with ads. What makes it tricky though is YouTube sometimes yells at me if I post the same video, one in the member section and one in the public section, because it's like considered the same content and the only thing is whether the video is monetized. So I'm trying not to get in trouble with the powers that be. So yeah, that's awesome, Becky. I love that. It seems we were really triggering like the Facebook algorithms for a period of time there. And it seems like it's kind of teetered off, but maybe we can spike it again. Because for a while there, we were actually getting as many subs and visibility. There were actually a couple that broke over like 100,000 views. I think there was one that broke over 1 million views on Facebook. And I think maybe we've done that on IG a couple times, but the IG stuff just gets like a lot more visibility. I was really surprised. I can't remember what. It was a video on. It was a clip on the court ruling against Google's AI summaries and how they're responsible for misinformation. That's what it was. Yeah, awesome. Love that, Vedran. Okay, team. I think we're... Yeah, I absolutely agree with this, Alex. This is much more my setting, is chill AI information with rational people that are not trying to cause fear and panic and all this chaos. More just what's going on, not trying to sell it as hypey, whatever, but more kind of like the things that you might want to need to know and how things are evolving. That's very much my approach. Love that. Oh, the link for the Discord, hopefully you saw it on the restream. Oh, did I not drop that on? No, I forgot to drop it on the IG. Hold on. There we go. Now it's on the IG as well. Okay. Okay, Huso, thanks for coming. All right, guys. This has been super fantastic. 2 days in a row. Glad we did this. And I will be chatting with you at the very latest tomorrow. But I might just pop on later tonight and do, yeah, I do need to pin it. Maybe somebody can help me figure that out. I think it's on the actual IG account somewhere. Right? If you click on this, oh, no, it's not. Let me fix that on IG. I'll fix that as soon as we hang up. Thanks for the tip, Dark. Appreciate it, guys. All right, folks. As always, keep going, keep growing.